Okay, there are some type of chemical reactions. Types of chemical reactions that are redox. Please take note that all synthesis reaction, all synthesis or combination, all synthesis or combination reaction are redox. All of them are redox. A synthesis reaction is a reaction in which you have reactant A plus reactant B is AB. That is a synthesis reaction. Okay, reaction from elements plus elements equals to compound are synthesis reaction. For example, I can have this synthesis reaction between two substances A plus B. Maybe I have something like carbon plus O2, which synthesizes CO2. Is redox reaction. Is a combustion reaction. Combustion reaction is a synthesis reaction. So all reaction of this type is redox because see, both of them are zero, being that they are not combined. But now that they are combined together now, since O2 here is -2 here give me -4. So what will actually be here so that everything becomes zero is +4. So we call it carbon 4 oxide. So you see now from this reaction now, carbon from here to here has oxidized. Then this from here to here has what? Reduced. So in a reaction in which oxidation, reduction occur at the same time, that's redox from the definition of redox. So all reactions of this sort, they are all what? Redox reaction. Suppose I have something like, I want to synthesize ammonia from Haber process. This Haber process, NH3, 2 here, 3 here. This is redox reaction. How is it redox reaction? Because we have here 0, here also 0, and here we have -3, here we have +1. Some reaction has reduced here. Which one has reduced here? This one has reduced here. This is reduction here. And this one has what? Oxidized here. So this is synthesis reaction or combination reaction. All of which are all what? Redox reaction. In other development, all displacements, reactions are redox. A displacement reaction of this nature will be maybe have a reaction A plus BC, and then again you're having AC plus B. It means that this reaction that A has actually displaces B, and for A to displace B from that compound, it must be that A is more reactive than B. Okay, there are some reactions that are like that. And for you to understand that reactions very well, you go to my video on electrolysis, where I discuss some electrochemical series, where I will discuss activity series of some elements. There are some elements, how we arrange elements in terms of the electropositivity or reactivity. Some elements are more reactive than the others. So from that reactivity, there are some elements, like we have copper and hydrogen in compounds. If I have copper, for example, copper compound, copper oxide, copper 2 oxide plus hydrogen here, in the reactivity series of metal, hydrogen is more positioned. Hydrogen is more reactive than copper. So hydrogen is going to use that position to displace copper from this compound by snatching that oxygen to form H2O, and then copper is reduced. This is displacement reaction. But how is it redox? It's redox because copper here is +2. This man is 0. But coming here, copper has reduced and hydrogen has what? Oxidized. So from here to here is redox. From here is oxidation. So it's redox reaction. But to know what has happened in this reaction is you need the knowledge of reactivity series. Just like if I'm talking about a reactivity series of the halogens, where you know that they go to the halogens of group 7 element, they now see that their reactivity decreases down the group. The most reactive non-metal of the group 7 is fluorine, followed by chlorine, then bromine, and then what? Iodine. Going down here, reactivity decreases. Which is most reactive? There is fluorine. Suppose I have a compound of potassium bromide solution, potassium bromide solution, that react this potassium bromide with chlorine. What is going to be the product form? I should use the activity. Chlorine, which is more reactive than bromine, in this activity displaces bromine from this aqueous solution to form 2KCl. So always make sure it's balanced. 2 KCl, now it becomes the aqueous. Then bromine is now what? Displaced. It's a displacement reaction. But how is it redox here? If K is +1, by the virtue of element in group 1, bromine will definitely be -1. This will be 0. K will still be +1. This is going to be -1. This is going to be what? 0. So in this reaction, bromine from here to here has oxidized. Then chlorine from here to here has what? Reduced. I can equally state the one which is oxidizing and the one which is what? Reducing. In this reaction, since chlorine has actually reduces in this reaction, chlorine is the oxidizing agent. And then KBr is the reducing agent. That is displacement. So all reaction of this type, they are all redox reaction. And then we have another redox reaction, a very important redox reaction, but that will be for some, not all. Some, not all. Some decomposition reaction. Whenever we say this decomposition, that means there's single decomposition, not double decomposition reaction. Not all. Some single decomposition reactions are redox. Some are redox. Some are not redox. I'll start with those that are decomposition reactions that are not redox. Suppose we have CaCO3. It actually decomposes. How to know what is going to come out here depends on how you can break these two up. By heat, this decomposes to calcium ion because it's in group 2, and this is going to carry 2 charge. Okay, this cannot further decompose, but this can still decompose again to form a stable CO2 and then O2 minus. So I think these two are actually going to combine since they are unlike charge and they have equal charge. So here it's going to come out CaO plus CO2. So that is what is formed when it decomposes. So let's check if it's redox. This is +2, this is +4, this is -2, this is +2, -2, +4, -2. So I don't think there has been any change in the states of any element here. This is the same here, no change. Carbon is the same here, no change. Oxygen is the same both sides, no change. So this is not redox reaction. So that's why I say some. So this type of single displacement reaction is not redox. Or if you check other displacement reactions that are not redox, maybe I'll give you 2 or more examples that are not redox. Okay, another example that are not redox, you can pause the video to see if you can decompose this compound easily. NaHCO3. Let's see if you can decompose this and see if it's redox. Let's see if it's redox. So we first decompose this way. Since sodium is in group 1, so here is with charge. Here we see HO3 minus going like this. H plus CO3 2 minus again O2 minus and CO2. So this cannot combine with this again, but this we actually go with this to form what? Make sure that will be 2 here, because since this is -2, so 2 will be here, so you can balance. So you have Na2CO3. So 2 will actually go here. So this is going to be 2 again, so we can combine with this with charge balance. So go together, we have plus H2O, and then what goes here again plus CO2. Check if it's a redox reaction. This is +1, this is +1, +4, -2, +1, +4, -2, +1, -2. No change. So it is not redox reaction. Okay, let's see if this could be redox. KClO3 decomposes. What has it got to give us? Here will be K plus ClO3 minus. So this will be in the case of decomposition, which is Cl minus plus 3O2 minus. So these two will go together to give me KCl plus 3O2. Okay, if 3O2 is there, that means 2 will be here, 2 will be here, so the equation can be balanced. Let's check if it's redox reaction. K is +1 minus 2. What is chlorine? You can try to puzzle it and solve it. You have KClO3. Let everything be equal to 0 here. K is +1 being placed in group 1. Here is X3 minus 2 equals to 0. So here is plus 1 plus x minus 6 equals to 0. So here we have x is equals to plus 1 minus 6 is minus 5. So minus 5 goes over, it becomes plus 5. Plus 5. So here is plus 5. That is potassium trioxochlorate 5. So here is plus 1 minus 1. Here is 0. So from what we have here, forget about potassium is not changing, but chlorine has changed from plus 5 to minus 1. Actually, this is reduction. Oxygen has changed from minus 2 to 0. Actually, this is oxidation. So this sort of decomposition reaction is redox. But in this reaction, something unique happened here. In this reaction, only one compound is behaving as oxidizing agent and reducing agent. Only one compound oxidizes and at the same time reduces. So when you see this reaction, in this reaction I can say that KClO3 has undergoes disproportionation. What does this word mean? It means that when the substance acts as both oxidizing and reducing agent. In this reaction, KClO3, chlorine in KClO3 has reduced here. So having reduced here, KClO3 is now acting as oxidizing agent. In this same reaction, oxygen in KClO3 has oxidized here. Okay, in this same reaction, having oxidized here, it is also acting as reducing agents. So in this reaction, when a substance acts as both reducing and oxidizing agent, the substance is said to have undergone disproportionation reaction. So in this reaction, KClO undergo the disproportionation. I would like to give you other example, maybe one more example of decomposition reactions that are redox. Apart from this, you can have this peroxide. Yes, peroxide can actually decompose to have hold of oxygen. So I think it's balanced now. We have this now. Okay, what is our take on this? This is actually plus 1, but this is not minus. Remember, this is not minus 2, but minus 1. This is plus 1, this is minus 2, this is 0. In this reaction, there has been a change of this to minus 2. Actually, it's reduction. Still on this, oxygen here has changed from minus 1 here to 0. This oxidation, of course, this reaction is redox. But in this reaction, just like KClO3 is undergoing disproportionation, H2O2 has also undergone disproportionation. What does it mean? It means that in this reaction, H2O2 oxidizes and at the same time reduces. It oxidizes here and here. So in this reaction, it acts as both oxidizing and then at the same time reducing what? Agents. There are some most reactions that are disproportionating, where sometimes if you even react chlorine plus water, which gives you HOCl plus HCl. That is what we call chlorine water and hydrochloric acid. In this reaction again, chlorine in this reaction has undergone disproportionation, even though that this reaction is not decomposition. There is nothing decomposed, it's an additional kind of plus water, giving you chlorine water, because actually this man is 0 here. Okay? This man is plus 1 here, this man is minus 2 here, this man is plus 1 here, this one is minus 1 here. So definitely, oxygen here will be what here? Oxygen here. Sorry, this can never be minus 1 or plus 1 because sum of everything will be 0. So here, oxygen will always be plus 2. So if you add this 2, that gives you, if you add this 2, that is going to give you, okay, if you add this 2, my plus 1 minus 2 give you minus 1. Plus 1 minus 2 give you minus 1, minus 1 plus 1 give you 0. So let's call oxochlorate 1 acid. Here we have plus 1, definitely here will be minus 1. Okay, this reaction, chlorine coming over here has oxidized. Then chlorine going over to HCl has reduced. There is nothing this water is doing in this reaction because there has not been any change. H is still the same thing at both sides. O is still the same thing at both sides. So the only one that has changed from one form to another is chlorine. So this chlorine, since chlorine is behaving as oxidizing and also reducing agents, chlorine in this reaction has undergone what we call disproportionation. When the substance behave in this manner, oxidizing and reducing agent, that is when the reaction, the substance are said to have undergone disproportionation as chlorine does in this reaction. Bromine can also do this. When bromine react with water, it gives you like oxobromic acid and then hydrochloric acid. That reaction also is a kind of disproportionation reaction of most of these halogens. And sometimes we can also look at this redox reaction of chlorine with alkali. Maybe conditions will be hot alkali or maybe cold alkali. Maybe chlorine can be react with cold alkali under a stable condition, cold alkali. Maybe chlorine reaction of chlorine with cold and hot alkali. Let's say chlorine is going to have undergo that disproportionation here. So what we have Cl2 plus NaOH. What's going to come out here will be 2 salt of NaCl, NaClO plus H2O. Okay, I think 2 should be here to balance the equation here. Okay, sometimes there is more to this reaction on the board. More to the reaction on the board in the sense that, okay, here we have chlorine is 0 here, chlorine is -1 here, chlorine is still +1 here. Why +1? Because already this one is -2. This one must, the 2 of this must give you 2, so that -2 will give you everything here to be 0. So you now see that in this reaction, only chlorine, sodium actually is not doing much in the reaction, it's still +1. Oxygen is not doing much, here is -2, both sides, -2, -2. So there is not actually, in this reaction, they are just moping, just being a spectator in this reaction. So they are not participating in the reaction. So in this reaction, chlorine is 0 here, but not 0 here. So here, there has been what? A clear case of reduction. And then the same chlorine coming over to the next compound here has oxidized. So what has happened here? Chlorine has undergone disproportionation. It acts as both oxidizing and then reducing agents. Now, this is another case of a redox reaction in non-acidic medium, but in alkaline medium. I can just design this way. I can say that Cl2, sort of this is an alkaline. I can use this OH minus this way. Okay? I can have only that I need in the reaction is only ClO. That's all. So if this go, this becomes ionic. Okay, so I can decide to do away with this and just have these reactions, only this reaction Cl2. What do I do to balance this reaction in acidic medium? I know that only oxygen is here. So what I just need to add is only 1 molecule of H2O to balance this oxygen. Because here I'm going to come over here, instead of writing hydrogen, because I'm balancing in alkaline medium, I write hydroxide ion. Since there are 2 of these here, 2 should be here. If I check my equation is balanced, except this, I know the reason why I'm going to balance this now. Okay, now what do? I'll try to check the net charge on the reaction on both sides. Yes, the net charge here is -2. This is this is 0, -2. Total net charge is -1. So I need the both sides to be balanced, -2, -2. So here we will carry extra electron to balance it. I think this is what we have here. 2 of this balance, 2 of this Cl2, and the other thing can come. This is when you balance this redox reaction in condition of cold. This is what you have. But if it's a condition of hot, if it's hot alkali, we have Cl2 plus NaOH, NaCl, but this I have NaClO3 plus H2O. Okay. In this equation now, I can say, okay, just try to see how it is in this way. So I'm going to have Cl2 versus this will go. I have only ClO3 minus. What do we do? Since I have only 3 of this, I'm going to add 3 of this. And then coming over here, 3 times 2, so I'm going to have 6 of alkali here, minus. Total here is -6, here is -1. So here add 5E minus. So it seems as if the reaction is balanced. So to balance this one is very, very simple. Since this is 6 here, so this is the same thing. So 6 will go here. Okay, 6 will go here actually. So when 6, so I have 6, since 6 I've gone here now, so I'll try to make sure that this is balanced. How many water is here? 3 should be here. This is what I have here. And then since I have 1 here, 1 here, so I cannot have 6. If I have 6 of this here, that means adding this one will give me 6, 7. So here we'll have 5 here, just 5 here, and then with 1 here. 5 here, 1 here is 6 balanced. So I have 5 chlorine, 1 chlorine, 6. So I still have to add 3. So normally I'm supposed to add 3 here because of this. So I'm going to add up 3 here to see if it's going to balance. Okay, now let's check if the question is balanced. We have 6 of this here, 6 chlorine here, 5 plus 1, 6. 6 sodium here, 5 plus 1, 6. 6 oxygen here, 3 here, 3 here, 6. 6 hydrogen, 3 times 2, 6. So when you have this chlorine reacting with this when it is hot, this is what you are going to obtain. In this reaction, chlorine also undergoes its proportionation. What do we mean by that? Chlorine here reduces, chlorine here oxidizes. Look at it here. This is where it is plus 5, and this is where it is what? Minus 1. So only chlorine in this reaction is the one that has been reducing, and that is the one that has been oxidizing. So that is why it is in the reaction disproportionality. But in the reaction where we have KBr solution plus Cl2, well, let's see whether there will be a disproportionation of chlorine or bromine. In this case, where we have KCl2 plus Br2. So we go here. So here minus 1, here is 0, here is minus 1, here is 0. So I don't think chlorine has undergone disproportionation here. No, because one is acting as reducing, one is acting. So chlorine here acts as oxidizing agent. Chlorine here only acts as oxidizing agent because it has reduced. While bromine here acts as reducing what? Agent. So there is not a case of disproportionation in this reaction. The only way we have disproportionation is when one substance is acting as both oxidizing and then reducing at the same time. Please, if you want more questions on this, we have solved a couple of these questions in JAM, past question, GCE, several questions on this have been solved. So you go to the link and see more of this. I think at this point we have to call it a day on this topic. If you have your question, go to the comment section and drop it there. Thank you very much for watching.